In the darkness between stars there are stories untold, whispers carried across light years that we might never hear. The universe keeps its secrets close, revealing them only in fleeting moments of cosmic serendipity, when something ancient brushes against the edge of our understanding. These moments come rarely, like the gentle touch of wind on still water, barely perceptible yet profoundly changing. They arrive not with fanfare or apocalyptic grandeur, but in the quiet observation of something that doesn't quite fit our understanding of how things should be. Something that makes even seasoned astronomers pause and wonder if they've truly seen what their instruments tell them they have. Something that makes us question not just what we know, but how we know it. Tonight we drift together into such a moment, a tale of visitation, of silent passage, of something that came from beyond our familiar shores. Not a story of invasion or spectacle, but of quiet presence. A cosmic whisper that, for those who listened closely, spoke volumes about our place in the grand tapestry of existence. As your consciousness settles into this journey, remember that the greatest mysteries aren't those that frighten us, but those that remind us how small we truly are beneath the weight of infinite possibility. The truly profound questions aren't answered with data points and measurements, but with the silent awe that comes from standing at the edge of comprehension and peering into the vast unknown beyond. Close your eyes. Let the weight of daily concerns fall away. The night is long, and this story moves at the pace of starlight crossing the void. Patient, inevitable, eternal. The stars have stories they've been waiting eons to tell, if only we would listen. It began with a faint shimmer in the outer darkness, a quiet disturbance at the edges of our solar system, where instruments strain to separate signal from noise. Here in the cold frontier beyond Neptune's orbit, the sun appears as merely the brightest star among many, its warmth a distant memory, its gravitational embrace weakened to a gentle tug. It is a realm of ice and silence, where objects drift in slow orbits measured not in years but in centuries. In this twilight zone between what we call ours and the true interstellar wilderness, humanity's electronic senses reach out like delicate fingers, feeling for perturbations, for echoes, for anything unexpected. Astronomers at the Mauna Kea Observatory first noticed it in their routine survey data on a cool October evening, a point of light that wasn't where it should be, moving in ways that defied local celestial mechanics. At first they suspected an error, perhaps a glitch in the imaging system, or a previously catalogued trans-Neptunian object that had been misidentified. But as confirmation came in from other observatories, from Chile, from Arizona, from orbital platforms, the reality became undeniable. Something was entering our solar system from elsewhere. They called it 3I Atlas, the third interstellar object confirmed to enter our cosmic neighborhood. I for interstellar, 3, because it followed the historic visits of Oumuamua and Borisov, and Atlas for the asteroid terrestrial impact last alert system that provided crucial early tracking data. Unlike comets born from our own Oort cloud, this visitor carried the silence of countless other stars in its composition. It approached without fanfare, without the dramatic tales of ice and dust that announce a comet's passage, without the predictable orbit of an asteroid. Just a soft reappearance in December's long night, gliding back toward the warmth of the inner solar system with what seemed almost like purpose. Some researchers called it coincidence, an object caught in the grand gravitational dance of galaxies, its path intersecting ours by mere mathematical chance. Dr. Eliana Martinez at the European Southern Observatory calculated the immense timeframes involved. This object has likely been traveling for hundreds of thousands, perhaps millions of years. That its path brings it to our doorstep now is simply probability playing out across cosmic timescales. But others, even among the scientific community, found themselves drawn to more profound interpretations. Dreamers called it destiny, a message in material form, carrying some profound truth across the emptiness between stars. But everyone who turned their gaze upward agreed on one thing: it was coming closer. Each night, instruments tracked its subtle acceleration, its unwavering course. As it crossed the invisible boundary of Neptune's orbit, entering the planetary region of our solar system, its presence created a curious feeling among those who studied it. Not fear, not excitement, but something harder to name. A sense that in the quiet between stars, something ancient was remembering us. In the oldest silence we've ever measured, something was moving with intention. Unlike asteroids or comets that faithfully orbit our sun, 3I Atlas didn't belong anywhere in our celestial family. Its origin lay elsewhere, perhaps in a star system we can see but cannot reach, or perhaps in one long extinguished, its planets and possibilities scattered to cosmic dust eons before humanity first looked skyward. The calculations performed by orbital dynamicists were definitive. Its hyperbolic trajectory confirmed an origin beyond our solar system, with a velocity vector that, traced backward through space and time, pointed toward the constellation Cygnus, the celestial swan. But that direction revealed little. During the immense time frame of its journey, stars themselves had moved, constellations had shifted. Its true birthplace remained as enigmatic as its composition. It wasn't born from the sun's cradle, nor tied to any familiar orbit. It was truly the third known interstellar visitor, an object from another star, carrying the silence of 1,000 forgotten systems. Early observations yielded frustratingly little data. Spectroscopic analysis revealed few definitive signatures, as if the object absorbed more questions than it answered. Its composition remained uncertain, its surface properties inconsistent with known formations. Attempts to determine its size and mass produced contradictory results. Larger telescopes somehow measured it as smaller than what modest instruments detected. Dr. Wei Chang at the Jet Propulsion Laboratory noted in her preliminary report, "It's as if the object's physical parameters shift depending on how we observe it, a phenomenon more consistent with quantum uncertainty than macroscopic bodies." Its behavior, too, proved unpredictable. Unlike Oumuamua, the first interstellar visitor that tumbled chaotically through our system in 2017, 3I Atlas moved with an almost elegant steadiness, rotating at a pace so regular it seemed intentional, maintaining a constant orientation relative to both the Sun and, curiously, to Earth. Long exposure photographs from Chile's European Southern Observatory showed not a point, but a faint, elongated shadow, suggesting a shape that resembled nothing familiar in our catalogue of asteroids and comets. Some images hinted at symmetries that rarely occur in natural objects, curves too perfect, angles too precise. Professor Hiroshi Yamamoto of Tokyo University described it as a shape that seems to fold in on itself, in ways that defy our understanding of how material objects should behave in space. Night after night, as telescopes captured its silent journey through the outer solar system, astronomers began to speak of it differently in their late-night discussions over cups of coffee grown cold and forgotten. Where scientific papers maintained clinical precision, the object transits at approximately 26 kilometers per second, private conversations took on a different tone. It doesn't move like other interstellar objects. It seems to know where it's going. It moved not like a rock, but like a thought crossing the void, purposeful, patient, present. Even gravity seemed to treat it with a kind of reverence we'd never seen before. Telescopes around the world turned to face it, their glass eyes gathering what little light reflected from the visitor's surface. From the massive mirrors of Mauna Kea to the linked arrays of radio dishes in New Mexico's plains of San Agustin, from Chile's high desert observatories to the infrared sensors of orbital platforms, humanity's collective astronomical apparatus pivoted toward this silent traveler. Graduate students abandoned scheduled research to join the growing observation efforts. Telescope time, normally allocated years in advance, was hastily reassigned. A quiet excitement built within the astronomical community, not the public frenzy that accompanies discoveries announced in press conferences, but the deeper, more private wonder of specialists who recognize that they stand at the edge of something unprecedented. On December 15, 2025, the projections aligned. A close pass near Earth's orbital path was inevitable. Scientists at NASA's Center for Near-Earth Object Studies calculated and recalculated, confirming what many had suspected. 3I Atlas would pass within 4 million miles of our planet, close enough to study in unprecedented detail, yet far enough to pose no threat to Earth or its satellites. Their public statements emphasized this safe distance, roughly 17 times the distance to our moon, while privately they marveled at the precision of the approach. The night would shimmer slightly differently, they said, in briefings to government officials and media outlets. Small gravitational ripples might disturb satellite orbits temporarily, requiring minor adjustment burns. Light distortions might be observable from certain radio telescopes. As the object's mass bent starlight passing, nearby, an opportunity for testing Einstein's relativity predictions with an object of unknown composition. Nothing catastrophic would occur, nothing to warrant public concern. Yet as the predicted trajectories were refined with each new observation, something about the path felt almost deliberate. The object had traveled for perhaps millions of years, traversing the unimaginable emptiness between stars, yet its course brought it precisely through our cosmic neighborhood, curving around our sun like a whisper, finding its way homeward. It would pass near no other planets, not massive Jupiter with its overwhelming gravitational pull, not ringed Saturn or ice giant Neptune. Only Earth. At the International Astronomical Union's Emergency Summit, held virtually to accommodate scientists from every time zone, the Brazilian astronomer Dr. Helena Covas voiced what many had been reluctant to say: "It isn't the distance that unsettles me, it's the direction of its gaze." Her metaphor proved unexpectedly apt. For somehow as it approached, instruments detected that 3I Atlas maintained the same face toward our planet throughout its approach, as if watching us through some cosmic eye. This orientation defied the simple physics of orbital mechanics, which should have caused the object to tumble or rotate along its path. Whatever 3I Atlas was, it seemed to have preferences about how it presented itself to Earth. Some visitors don't need an invitation, they already know they're expected. In observatories circling the planet, equations replaced sleep. The silent mathematics of celestial mechanics, the differential equations that govern how objects move through space under the influence of gravity, suddenly seemed inadequate. Their clean simplicity complicated by anomalous data points that refused to align with predictions. Cosmologists and orbital dynamicists worked through nights that blended into days, attempting to bring certainty to an object that defied it. Their monitors glowed in darkened control rooms, casting blue light on faces marked by equal measures of fascination and frustration. Predictions bent and reformed, like waves meeting stone, each new observation forcing recalibrations that sent cascades of changes through their models. The Jet Propulsion Laboratory created 17 separate model scenarios, each collapsing under new data that arrived hourly. Teams at NASA, the European Space Agency, and China's National Space Administration independently reached the same troubling conclusion. Standard gravitational models failed to fully account for 3I Atlas's behavior. Every recalculation offered a new story. Collision remained unlikely but not impossible. The object's mass estimates fluctuated beyond normal measurement error, sometimes appearing to increase temporarily, before returning to baseline values. Its albedo, or reflectivity, seemed to shift depending on which telescope observed it, as if it presented different aspects of itself to different observers. The more they measured, the less they understood, as if 3I Atlas was writing its own variables into the cosmic equation. Dr. Michael Chen at Caltech observed that it's as if we're trying to predict the behavior of a living thing using physics designed for inert matter. His comment, meant as a metaphor, was struck from the official report but circulated widely among the research teams. At Cambridge University, a team of theoretical physicists noticed something else, a subtle gravitational anomaly that suggested the object possessed unusual density properties. Using detailed measurements of how the visitor's gravity affected nearby micrometeorites, they detected inconsistencies that defied standard models. It's as if parts of it exist in different relation to space-time than others, noted Dr. Wei in her preliminary report, though she cautioned against exotic explanations like negative mass or extra-dimensional properties. Yet among the forest of numbers and probability curves, patterns began to emerge, not in the answers but in the questions themselves. The anomalies showed their own peculiar regularities, as if the object's deviations from expected behavior were themselves following some deeper pattern. And the numbers began to sound like riddles left by something that had already passed this way before, tests designed to see if we had advanced enough to recognize their significance. The equations weren't failing, they were speaking a dialect of mathematics we hadn't yet learned. Some researchers, finding little comfort in conventional explanations, suggested that 3i Atlas might be ancient, older than our Sun, older even than our galaxy's current spiral formation. In quiet conversations after formal meetings, in emails exchanged between trusted colleagues, in hypothetical scenarios labeled clearly as speculation, they explored possibilities that strayed beyond the boundaries of mainstream astronomy. A wanderer from the early universe, perhaps, when matter first coalesced into structures large enough to travel between forming star systems. A remnant from before the current epoch of cosmic evolution, carrying in its composition elements, formed in the crucible of the universe's youth. Dr. Ananya Kapoor at Princeton proposed in a controversial paper that it might be a fragment of an extinct civilization's wanderings, not a spacecraft in any recognizable sense, but a remnant of attempted contact from beings long vanished from the cosmos. If we accept the possibility that other intelligences have arisen elsewhere in our galaxy's long history, she wrote, we must also consider that some might have reached beyond their home systems, sending emissaries that continue long after their creators have disappeared. Her paper was rejected by 3 journals before finding publication in a specialized cosmology quarterly, yet it was downloaded more times in its first week than any other paper in the journal's history. Others insisted it was simply a rock, albeit an unusual one, carrying frozen starlight and cosmic radiation from another star's neighborhood. Extraordinary claims require extraordinary evidence, reminded Dr. Hiroshi Takamoto of Tokyo University, quoting Carl Sagan's famous dictum. And what we have is an extraordinary object with insufficient evidence to determine its true nature. No evidence supported either extreme, yet absence of evidence rarely quells human imagination. The public, too, began to engage with the visitor, in ways both scientific and spiritual. Viewing parties organized in dark sky preserves around the world, though the object remained visible only to instruments, too faint for the naked eye. Online forums tracked its approach with a mixture of anxiety and anticipation. Religious leaders offered interpretations ranging from divine messenger to harbinger of apocalypse, while physicists appeared on news programs explaining hyperbolic trajectories and interstellar medium interactions. Yet beneath these divergent reactions ran a common current. The idea that this object had seen other worlds stirred something quiet and human in us all. Because what if we weren't its first curiosity? What if, in its patient journey between stars, it had witnessed the rise and fall of other beings who once looked up with wonder just as we do now? What stories could it tell of civilizations that bloomed and faded while it drifted, silent and watchful, through the cosmic dark? Perhaps it carries the whispers of 1,000 extinct worlds in its silent passage. Spectral analysis revealed strange reflections, faint patterns that seemed to repeat across the object's surface when viewed under specific wavelengths of light. Using advanced filtering techniques to isolate particular frequencies, scientists at the European Space Agency detected symmetrical yet imperfect formations, like eroded glyphs or etched memories preserved in ancient material. When viewed in the ultraviolet spectrum, these patterns formed geometries that reminded some researchers of mathematical constants, not quite matching pi or phi, but suggesting similar conceptual elegance. These patterns defied natural explanation. They weren't impact craters or crystalline structures known to form in space. They didn't match the fractal patterns of ice formation or the chaotic distribution of cosmic ray impacts. They possessed a quality that Dr. Sarah Mbeki of South Africa's Cape Town Observatory described as ordered complexity, too regular to be random, too varied to be simple. Under ultraviolet observation, they seemed to pulse with subtle luminescence that couldn't be attributed to reflected sunlight alone, as if responding to observation itself. The patterns appeared stronger when multiple telescopes observed the object simultaneously, weaker when only a single instrument was trained upon it. Could light carry intention across the void? Could patterns encode meaning beyond their physical arrangement? Could the mere act of observation elicit response, as in quantum physics where the observer affects the observed? Or was it our longing for meaning that filled the cosmic silence with imagined voices, our pattern-seeking brains finding significance in random configurations of matter? Dr. Hamid Nouri of the International Astronomy Union urged caution in an emergency symposium held as the visitor crossed Mars's orbit. We must be careful not to project our hopes onto this visitor, The human mind seeks patterns even in randomness. We see faces in clouds, messages in static. Yet even he admitted that certain arrangements seemed to repeat with mathematical precision that resisted probabilistic explanation. A team at SETI, the search for extraterrestrial intelligence, began running the observed patterns through decoding algorithms designed to identify potential non-random signals. They applied the same techniques previously used to analyze radio signals from deep space, looking for prime number sequences, mathematical constants, or binary encodings that might suggest artificial origin. Nothing conclusive emerged from these analyses, yet the attempts continued night after night as 3i Atlas drew closer to Earth. Because sometimes the universe doesn't send messages. It waits for us to imagine them, to project our own meanings onto the cosmic canvas, and in that projection, perhaps, to learn something about ourselves we couldn't discover any other way. The patterns weren't written for our eyes, but our eyes couldn't help but search for meaning. As December drew near, Earth grew watchful. The approaching visitor had moved from specialized scientific journals to mainstream news, from academic conferences to dinner table conversations. In the hum of cities and stillness of deserts, people felt the same invisible weight, a visitor arriving from beyond comprehension. The sensation wasn't quite anticipation, wasn't quite dread, but something more primordial, the feeling of being observed by something ancient and inscrutable. Schools organized special observatory nights, wheeling out telescopes onto playing fields, where children lined up to glimpse what most instruments couldn't even detect without advanced imaging. News programs featured nightly segments tracking the approach, with animated graphics showing 3i Atlas's trajectory through our solar system, a curved path that seemed to embrace our sun before continuing onward into the cosmic deep. Social media filled with both scientific discussion and wild speculation, with hashtags like #CosmicVisitor and Star Stranger trending globally. Memes proliferated, some treating the object as a cosmic tourist disappointed by Earth. Came 5.7 trillion miles, and all I got was this lousy gravity assist. Others suggesting it carried messages from long-vanished civilizations. Yet beneath the public discourse ran a deeper current, not fear but a collective holding of breath. This wasn't a threat but a presence, a reminder that our planet drifts through a cosmic ocean too vast to chart, too deep to fathom, where other entities move according to purposes we might never comprehend. Strange reports began to emerge from around the world, though most lacked verification. Fishermen in coastal villages from Japan to Chile reported unusual bioluminescence in night waters, patches of glowing blue that seemed to pulse in rhythms matching the rotational period of 3i Atlas. Migratory birds seemed to alter traditional patterns, circling in unusual formations before continuing their seasonal journeys. Whales near Iceland began singing in modified vocalizations that marine biologists found structurally different from their usual songs. These phenomena likely had mundane explanations, coincidences of timing, normal variations now noticed due to heightened attention, yet the timing created a sense that Earth itself recognized something in the approach. Indigenous communities from Australia to the Arctic held ceremonies honoring the visitor, drawing on ancient traditions of celestial observation that predated modern astronomy by thousands of years. They built ceremonial fires visible from space, created intricate sand paintings that mirrored the object's calculated path, and composed songs that would be passed through oral tradition long after 3i Atlas had departed. "The stars have always spoken," explained Elder Joseph Two-Bears of the Blackfoot Nation during a gathering in Montana that drew participants from dozens of indigenous communities across North America. "We have simply forgotten how to listen. Our ancestors understood that visitors from the sky country bring teachings if we approach them with humility. And somewhere in that vast ocean of stars, something had noticed our small blue light, our radio broadcasts propagating outward at the speed of light, our city illuminations visible from space, our first tentative robotic emissaries to nearby planets, our nuclear tests and radar pulses and television signals, all announcing our presence to whatever might be listening in the interstellar silence. Our ancestors told stories of sky visitors. Perhaps they remembered what we've forgotten. When the object crossed into the inner solar system and caught the full radiance of our sun, Astronomers expected to observe the familiar behavior of comets, tails of vapor and dust streaming behind as ice sublimated in the warmth. All previous observations of cometary bodies had followed this pattern. Even interstellar visitor 2I Borisov had displayed a classic cometary tail as it approached our star. Instruments were calibrated to measure the composition of these expected emissions, to analyze the chemical signature of whatever volatile substances might be released. But none came. No coma formed around 3I Atlas, that cloudy envelope of gas and dust that gives comets their fuzzy appearance. No dust trailed in its wake. No ionized particles streamed behind it like a pennant catching the solar wind. It absorbed more than it reflected, a dark traveler against the golden glow, drinking in sunlight without response. Where comets typically brighten as they approach the sun, 3I Atlas maintained a consistent luminosity, neither flaring nor dimming as it plunged toward the inner solar system. Thermal imaging from the James Webb Space Telescope revealed unusual heat distribution. The object maintained near constant temperature across its surface, despite varying exposure to solar radiation. The side facing the sun should have warmed significantly, while the shadowed side remained cold, creating a thermal gradient that infrared instruments could easily detect. Instead, the temperature difference between sunward and shadowed faces remained minimal. "It's as if it's regulating itself," noted Dr. Sarah Chen of MIT in a hastily convened virtual conference, though she quickly qualified that natural explanations might still apply, perhaps a rapid rotation that distributed heat evenly, or some unusual material property that conducted thermal energy with extraordinary efficiency. The sky had never looked so silent as in those December nights, when people around the world stepped outside to search for a visitor that gave back so little of what it received. Though invisible to naked eyes, amateur astronomers with backyard telescopes described the experience of observing it as unsettling, not for what they saw, but for what they felt while observing it. "It was like looking at something that was looking back," reported one observer in New Zealand, whose statement was echoed by others across different continents. "I had the distinct feeling that I wasn't just seeing it, it was seeing me. Even the light seemed unsure if it should touch it, as if photons themselves hesitated before bouncing off this stranger to our cosmic neighborhood. It drank our sun's light like a desert traveler, finding water after an eon of thirst." Days before the closest approach, instruments across the planet began to flicker with unexpected readings. Magnetometers at geophysical research stations from Antarctica to Alaska recorded subtle fluctuations that couldn't be attributed to solar activity or Earth's own field variations. The planet's magnetic field, that invisible shield that protects us from cosmic radiation and solar wind, showed small but measurable perturbations, waves of influence that rippled outward from wherever 3I Atlas was positioned relative to Earth. Magnetic, readings shifted like whispers in static, not dangerous disruptions, just different. When plotted as waveforms, they resembled nothing so much as heartbeats or breathing patterns, regular yet organic, structured yet fluid. The patterns appeared almost rhythmic when plotted on time-sequence graphs, with periodicity that matched no known natural phenomenon but suggested intentionality in their precise repetition. Some scientists dismissed these as instrumentation errors or coincidental solar wind effects. "We're seeing what we expect to see," cautioned Dr. James Chen of Stanford's Advanced Physics Laboratory. "When you look for patterns with enough determination, you'll find them regardless of whether they objectively exist." Others suggested more provocative possibilities, that 3I Atlas might possess electromagnetic properties unlike any observed in natural objects, perhaps even generating its own field through some unknown mechanism. Dr. Elena Reyes of the Chilean Astronomical Society proposed that the patterns might constitute a form of greeting in the language of physics. If an intelligence evolved in deep space, perhaps electromagnetic communication would be more intuitive than our radio waves. A civilization that developed in the interstellar medium rather than on a planetary surface might naturally communicate through magnetic field modulations. Her hypothesis gained little traction among mainstream researchers, who pointed out the lack of evidence for any form of life capable of surviving in the vacuum of space. Yet the patterns continued, growing slightly stronger as the visitor drew closer, becoming more complex as if elaborating on their initial theme. Sensitive animals, migratory birds, deep-sea creatures, even some domesticated pets, showed behavioral changes that coincided with the strongest of these magnetic pulses. If space could hum, this was the sound of something remembering how, recalling a language spoken between stars, a communication method more fundamental than radio waves or light signals, written into the very fabric of space-time itself. The magnetic whispers weren't meant for our instruments, but for the Earth itself. December 15th arrived with a winter stillness that seemed to extend beyond Earth's atmosphere. Around the world, people paused in their daily routines, aware that something unprecedented was occurring even if invisible to human senses. The sky didn't erupt with celestial fireworks. It breathed. For one brief moment, as 3I Atlas reached its closest approach at 3:42 a.m. Greenwich Mean Time, twilight lingered longer than it should have along the terminator line between day and night. Observers in New Zealand, Australia, and the Pacific Islands reported an unusual quality to the pre-dawn light, a shimmering that seemed to bend the horizon itself, as if the atmosphere were rippling under some gentle pressure. The stars brightened, yet shadows softened, as if light was being refracted through something invisible between Earth and its visitor, something that bent photons in ways that defied optical physics. Colors shifted subtly. Sunrises and sunsets displayed hues that atmospheric scientists couldn't fully explain through standard light scattering models. The northern lights appeared unexpectedly as far south as Montana and Maine, dancing in patterns that aurora specialists described as structured yet unfamiliar, their usual curtains and waves forming into more geometric configurations. Atmospheric scientists detected brief fluctuations in upper atmospheric pressure waves that traveled around the planet 3 times before dissipating, like ripples in a pond but moving through air rather than water. Infrasound detectors, designed to monitor everything from elephant communications to nuclear tests, recorded deep tones below human hearing thresholds that emanated from no identifiable source. Some witnesses claimed the air itself shimmered, bending faintly as 3 Atlas passed through our shared gravity well, as if the fabric of reality had become momentarily less rigid, more fluid in its presence. No catastrophe occurred, no mountains crumbled, no tides surged beyond their normal reach. The visitor passed silently, its physical effects subtle enough that many people noticed nothing unusual at all. Yet something had changed in that moment, a cosmic breath held then released. It came and went like a dream that refused to end, leaving witnesses around the world with the uncanny sense that they had experienced something that existed at the edge of perception, something that human senses and human language were not quite equipped to capture. For weeks afterward, sleep researchers around the world noted an unusual spike in reports of vivid dreaming, dreams of stars speaking, of ancient memories surfacing, of standing in vast empty spaces filled with presence rather than absence. For one moment, the boundary between dreams and waking thinned like gossamer. After it passed beyond Earth's orbit, continuing its journey toward the outer solar system, radio telescopes recorded something unexpected, a soft pulse emanating from the direction of 3I Atlas. The signal appeared briefly at 142 GHz, a frequency that didn't match cosmic background noise or known stellar emissions. This frequency, 1420 MHz, held special significance in the search for extraterrestrial intelligence. It's the emission frequency of neutral hydrogen, the most abundant element in the universe. For decades, SETI researchers had monitored this frequency, theorizing that any intelligent civilization would recognize its universal significance. The pulse from 3I Atlas lasted for precisely 12 minutes, before fading into the background static of the universe. 12 minutes. The approximate time it takes light to travel from the sun to Earth. Too organized to dismiss as random noise, too faint to decode into meaningful patterns, it nonetheless captured the attention of researchers at radio observatories worldwide. The signal's structure showed modulations that couldn't be explained by natural phenomena, regular variations in amplitude and frequency that suggested deliberate composition rather than random emission. Scientists at the Green Bank Telescope in West Virginia, the world's largest fully steerable radio telescope, archived it as anomalous signal data, noting its unusual characteristics, while avoiding speculation about its origin in their official reports. But others, researchers working late shifts, graduate students with more curiosity than caution, independent radio astronomers with home-built equipment, listened to the recording again and again, claiming they felt something beneath the sound itself. When converted to audio, the pulse produced a low, rhythmic hum punctuated by irregular silences that some listeners described as almost linguistic, reminiscent of the cadences of human speech, but utterly alien in its actual structure. Dr. Maria Gonzalez, a linguist who specialized in communication theory, noted that the signal contained elements that appeared in all human languages: rhythm, repetition, variation within structure, yet organized according to principles she couldn't identify. "It feels like language," she wrote in a speculative blog post that later went viral, "but not language evolved to communicate through air on a planetary surface. Rather, it suggests communication adapted to the vast timescales and distances of interstellar space. It wasn't a message you could hear with ears or decode with algorithms. It was one you could feel, resonating not in the ear but somewhere deeper, as if recognition preceded understanding, as if the signal activated something dormant within human consciousness itself, some ancient receiver tuned to frequencies we had forgotten we could access. Some messages aren't meant to be understood, they're meant to be remembered." As calculations continued tracking 3I Atlas on its outbound journey, astronomers noted something that defied explanation. Its new trajectory seemed to shift course slightly, curving out of predicted paths in ways that Newton's laws couldn't comfortably explain. The object appeared to accelerate at points where no gravitational influence should cause such behavior, as if it had changed its mind about where it was going. The deviations were subtle but unmistakable. A few degrees of arc here, a slight velocity increase there, building over time into a path that diverged significantly from what celestial mechanics dictated. Natural objects don't do that. Comets follow the mathematics of orbits. Asteroids obey the pull of gravity. Even planets adhere to the elegant ellipses that Johannes Kepler identified 4 centuries ago. Yet 3I Atlas seemed to introduce a variable that wasn't accounted for in standard celestial mechanics, a factor that looked disturbingly like choice. Dr. Hiroshi Takamoto at Japan's National Astronomical Observatory proposed that outgassing, the release of volatile materials, might explain the anomalous acceleration, similar to the way Oumuamua had behaved during its 2017 passage. But spectroscopic analysis showed no evidence of such emissions, no change in the object's spectra, no visible jet that could provide propulsive force. Others suggested interaction with the interstellar medium. The thin soup of particles that fills the space between stars might create drag effects that could alter trajectory. But the math didn't support this explanation. The density of the interstellar medium was far too low to produce the observed changes. "Perhaps," suggested Dr. Takamoto in his follow-up paper, published in the astrophysical journal Letters, "in a universe of mysteries, our definition of natural is simply too small. We have built our understanding of physics on observations of our local environment, a single planet orbiting a single star. Maybe the cosmos operates according to principles we haven't yet grasped." The idea resonated beyond scientific circles, touching something philosophical in the public imagination. What if even stones have intentions, only too slow for us to see? What if matter itself, at some fundamental level, possesses a kind of primitive consciousness that expresses itself across timescales we can barely comprehend? The concept wasn't entirely without scientific precedent. Quantum physics had long suggested that observation affects reality at the subatomic level. Integrated information theory proposed that consciousness might be a fundamental property of the universe, present in varying degrees in all physical systems. Perhaps 3I Atlas represented a form of organization where such properties manifested at scales we could observe directly. What if the line between living and non-living is merely a matter of patience? People remembered Oumuamua, the first interstellar object confirmed to pass through our solar system in 2017. How it came and went with the same silence, leaving behind more questions than data. Its cigar-like shape, estimated to be between 100 and 1,000 meters long, but less than 100 meters wide, had defied classification, neither asteroid nor comet in its behavior. Its unusual acceleration, its lack of visible outgassing, all had prompted theories ranging from the mundane to the extraordinary. Harvard astronomer Avi Loeb had famously suggested it might be technological in origin, perhaps a solar sail or probe deliberately sent to observe our solar system, a hypothesis that earned both criticism and thoughtful consideration from the scientific community. Now, years later, 3i Atlas felt like Oumuamua's echo, its continuation, two notes in a cosmic melody we hadn't learned to hear yet, perhaps the beginning of a pattern that would continue with future visitors, each adding another note to this mysterious composition. The similarities were striking. Both objects reflected light in unusual ways, both accelerated inexplicably, both seemed to defy easy categorization within our existing taxonomies of celestial bodies. Yet the differences were equally compelling. Where Oumuamua tumbled chaotically, rotating every 8.1 hours and presenting different aspects to observers, 3i Atlas maintained stable orientation, as if deliberately controlling its presentation. Where Oumuamua was reddish in hue, suggesting a surface altered by millions of years of cosmic radiation, 3i Atlas absorbed almost all wavelengths equally, appearing as a void against the background of stars. It's as if they're different species of the same cosmic fauna, mused Dr. Carla Simmons, in her address to the American Astronomical Society's emergency session, using biological metaphors that raised eyebrows among the more conservative members, but seemed to capture something essential about these enigmatic visitors. Perhaps they represent different functions, different purposes, scouts and messengers, observers and recorders, and maybe, between those notes, something vast was trying to speak, a conversation occurring at intervals measured not in minutes or hours, but in years and decades. Perhaps we were hearing only fragments of a dialogue that had been ongoing since before humanity evolved. Signals passed between ancient sentinels, circling through the galaxy like silent shepherds, maintaining some vigil whose purpose we could not yet comprehend. The cosmic conversation was happening too slowly for us to hear, yet too quickly for us to ignore. It began on an ordinary Tuesday, when a notification pinged across the screens of astronomers worldwide. An object of unusual trajectory and velocity had entered our solar system. The Pan-STARRS telescope in Hawaii had captured it first, a small point of light moving against the fixed background of stars, following a path that suggested it came from beyond our solar family. Unlike comets that looped in predictable ellipses around our sun, this visitor traced a hyperbolic arc, a cosmic parabola that would bring it briefly near our world before carrying it back into the interstellar void. The astronomical community designated it 3i Atlas, the third confirmed interstellar object to visit our solar system. But unlike its predecessors, this one would pass close enough to Earth for detailed observation. Something ancient was awakening from the cosmic deep, and we were just beginning to feel its presence. Within hours of the announcement, telescopes around the world swiveled toward the approaching visitor. Radio telescopes strained their digital ears, listening for signals. Spectrographs split its faint reflected light into rainbow patterns that might reveal its composition. Radar arrays bounced invisible waves off its surface, hoping to map its contours. The data began flowing into research centers, universities and observatories, fragments of information about a traveler from beyond our known neighborhood. Initial measurements suggested an object roughly cylindrical in shape, approximately 400 meters in length, rotating slowly along its axis as it hurtled through space at nearly 26 kilometers per second. Its surface appeared reddish-brown, similar to certain asteroids in our own system, yet spectral analysis revealed compounds not commonly found in our cosmic vicinity, complex carbon chains that glowed strangely when illuminated by our sun. The stars had sent a messenger, but the language of its arrival remained untranslated. What made 3i Atlas particularly unusual was its apparent density. Radar reflections suggested it was not a solid mass, but contained internal spaces or variations, like a sponge or honeycomb structure. This was not unheard of in natural objects. Certain porous asteroids showed similar properties, yet something in the regular patterning of these internal variations caught the attention of Dr. Elena Morikawa at the Arecibo Observatory. The internal structure shows a level of geometric consistency that's statistically improbable, she noted in her preliminary report, a sentence that would be quoted in thousands of articles in the weeks that followed. Nature certainly creates patterns, but these specific arrangements, nested hexagonal chambers connected by regular channels, suggest either an unknown natural process or— She left the alternative unstated, but the implication hung in the digital spaces where her report circulated, or something designed. The boundary between natural wonder and intelligent design blurred with each new data point, like twilight obscuring the horizon. Within days of Dr. Morikawa's report, major observatories reported another anomaly. 3i Atlas had adjusted its trajectory. The change was subtle, a deviation of less than 0.03 degrees, but it occurred without any detectable gravitational influence that could explain it. No outgassing like that, which sometimes alters the paths of comets. No fragmentation that might change its momentum. Just a gentle, unexplained curve that would bring it slightly closer to Earth than originally calculated. The adjustment might have been explainable through complex gravitational interactions too subtle for our models to predict, perhaps influence from the larger Jovian planets or even the collective gravitational whisper of millions of asteroids. But the timing of the change, just after intense radar scrutiny from Earth, struck many observers as an uncomfortable coincidence. "It's as if it noticed us noticing it," remarked a graduate student at Chile's La Silla Observatory, a comment that would later go viral despite her attempt to retract it. "We had been watching the sky for centuries, never considering that it might finally decide to watch us back." NASA and the European Space Agency hastily assembled a joint task force to coordinate global observation efforts. The Minor Planet Center issued hourly updates on the object's trajectory, composition, and behavior. The International Astronomical Union held emergency sessions to establish protocols for studying this unprecedented visitor. Chinese, Russian, and Indian space agencies activated their own observation networks, sharing data through newly established channels. For perhaps the first time since the International Geophysical Year of 1957, scientific bodies around the world synchronized their efforts without political friction, unified by the silent approach of something that belonged to no nation, no planet, perhaps not even to our star system. Dr. Hiroshi Nakamura, head of Japan's National Astronomical Observatory, expressed the sentiment that seemed to guide this collaborative spirit. Whatever this object is, it reminds us that we are first citizens of Earth before we are citizens of any country. In the shadow of the unknown, our human divisions seemed suddenly small and translucent. As 3i Atlas drew closer, entering the orbit of Mars in early November, its peculiarities multiplied. Its albedo, the measure of how much light it reflected, fluctuated in patterns that defied explanation, as if its surface properties were changing in response to sunlight. Spectrographic readings detected traces of complex organic molecules, appearing and disappearing from its spectral signature, suggesting either outgassing processes or surface transformations as the object rotated. Most curiously, it emitted no radiation beyond the reflection of sunlight, no radio waves, no infrared beyond what would be expected from solar heating, no X-rays or gamma radiation. It was, in the electromagnetic spectrum, almost unnaturally quiet. This silence itself became data, a negative space that shaped our understanding of the visitor. "Sometimes what we don't detect tells us more than what we do," noted Dr. James Chen at Caltech's Radio Astronomy Division, "and this object is conspicuously quiet in ways that natural objects rarely are." The visitor's silence spoke volumes in a language we were only beginning to understand. By the time 3i Atlas reached lunar orbit in late November, it had become the most observed object in astronomical history. Every functioning telescope on and above Earth tracked its approach. Amateur astronomers with backyard equipment joined professional observatories in an unprecedented citizen science effort. Schools organized night-watching events. Religious leaders held services beneath open skies. News organizations ran 24-hour coverage, cycling between expert interviews and real-time imagery from observatories worldwide. Social media platforms created special tags and filters for content related to the visitor. For a brief moment, Humanity's divided attention unified around a single point of light, moving against the night sky. A common focus that transcended geographic, political, and cultural boundaries. Even if 3i Atlas turns out to be nothing more than an unusually shaped rock, wrote columnist Aisha Al-Farsi in the International Herald Tribune, its greatest achievement may be showing us how quickly we can come together when we perceive ourselves as a single species facing the unknown. Our collective gaze turned skyward, and in that shared looking, we glimpsed ourselves anew. Online, theories blossomed like night flowers, opening to reveal both beauty and confusion. The internet became a vast collective imagination space where scientific observation mingled with speculation, where data points became narrative threads woven into stories about what 3i Atlas might be. Was it alien technology, carefully disguised to appear natural? A probe sent to observe our civilization? A natural phenomenon revealing new physics? A message in material form? A warning? A greeting? A test? Discussions ranged from peer-reviewed scientific journals to midnight conspiracy forums, from university lecture halls to spiritual retreats where people gathered to connect with the visitor through meditation. Hashtags proliferated. There was Cosmic Messenger, there is Star Stranger, and this Atlas theory, each spawning its own ecosystem of ideas. Most theories were likely wrong, built on insufficient data or wishful thinking, but none were foolish. Because in the act of wondering, humanity felt unified for a brief moment, bound not by answers but by shared awe before the unknown. For perhaps the first time since the moon landings, people around the world shared a common focus that transcended national boundaries and cultural differences. Children drew pictures of 3i Atlas in classrooms from Tokyo to Toronto, giving it faces and feelings, some depicting it as a lonely traveler, others as a curious observer, others as a messenger bringing wisdom from distant stars. Poets wrote verses imagining its journey between stars, capturing in metaphor what science could only approach through measurement. Musicians composed pieces that attempted to capture the rhythm of its passage, solemn, patient compositions that unfolded slowly, mirroring the vast timescales of interstellar transit. A group of philosophers from universities across 6 continents issued an open letter to the cosmos, acknowledging that, while we might never understand the visitor's nature, the attempt itself represented something profound about human consciousness, our capacity to recognize mystery and respond with curiosity rather than fear. Even if we cannot decipher you, they wrote, we welcome the questions you bring, the possibilities you represent. Sometimes the truest signal isn't from the stars, but from the silence we fill together with our collective imagination, the stories we tell to make sense of what we don't yet understand, revealing more about our hopes and fears than about the phenomena that inspired them. In our shared uncertainty, we found a language beyond words. Dr. Samantha Reyes of Princeton University published a paper suggesting that 3i Atlas might be a fragment of a destroyed planet from another star system, carrying in its composition clues about worlds we might never directly observe. Her theory gained traction among astrophysicists studying planetary formation, who saw in the visitor's unusual density and composition possible evidence of geological processes different from those in our own solar system. If confirmed, Dr. Reyes wrote, this would represent our first direct contact with matter formed under the influence of another star, a cosmic fossil that could revolutionize our understanding of planetary evolution. Her team pointed to unusual isotope ratios detected in spectroscopic data, suggesting the object had formed in an environment with different nuclear synthesis histories than our own solar neighborhood. A world's memory had crossed the void, waiting for someone to read its ancient story. Meanwhile, Professor Hiroaki Tanaka from the Tokyo Institute of Technology proposed a more radical hypothesis, that 3i Atlas might represent an entirely new class of astronomical object, neither asteroid nor comet nor planetary fragment, but something formed through interstellar processes in the space between stars. He suggested that in the cold molecular clouds where stars are born, complex chemical and physical processes might create structured objects through mechanisms we haven't yet discovered. The universe is more creative than our theories allow, he wrote. Perhaps 3i Atlas represents a natural, formation process occurring in interstellar space that we've never observed because such objects rarely enter star systems where we might detect them. His theory sought to explain the object's unusual internal structure as the result of slow accretion in microgravity environments over millions of years. The cosmos crafts mysteries in workshops too distant for our eyes to see. More controversial theories emerged from the fringes of established science. Dr. Eliza Monteiro, a respected astrobiologist who had previously worked with NASA, suggested that 3I Atlas might be a dormant biological entity, something akin to a spore or seed designed to travel between stars. Her hypothesis drew on recent discoveries about extremophile bacteria that could survive in the vacuum of space when shielded from radiation, as well as theoretical work on panspermia, the idea that life might spread between planets via meteoroids or comets. The internal chambers we're detecting could be protective structures, she speculated in a paper that many of her colleagues criticized as premature. The organic compounds detected on its surface might be the equivalent of a seed coat, designed to withstand interstellar radiation and activate upon approaching a suitable star. Though considered highly speculative, her theory captured public imagination and sparked renewed interest in astrobiology. Life finds pathways where our imagination fails to tread. The artificial origin hypothesis, despite being approached cautiously by mainstream scientists, gained significant traction both in specialized journals and public discourse. Dr. Avi Bergman of Harvard, who had previously studied Oumuamua's unusual characteristics, published a paper outlining the case for considering technological explanations. While natural explanations should always be our starting point, he wrote, we must remain open to the possibility that we are observing something designed rather than something formed through passive natural processes. He outlined several characteristics that suggested possible technological origins. The precise geometric patterns in its internal structure, its unexplained course adjustments, and the unusual electromagnetic properties of its surface. Though careful to present his arguments as speculative rather than conclusive, his paper sparked intense debate in the scientific community about the proper protocols for investigating potential extraterrestrial technology. What if the line between technology and nature blurred across the vast distances between stars? Religious and spiritual communities developed their own interpretations of 3I Atlas, often integrating the visitor into existing theological frameworks. Vatican astronomers issued a statement affirming that the discovery of extraterrestrial life or intelligence would pose no fundamental challenge to Catholic doctrine, which had long acknowledged the possibility of other worlds created by God. Islamic scholars pointed to verses in the Quran that spoke of God's creation extending beyond Earth. Buddhist teachers emphasized the interconnectedness of all phenomena across cosmic distances. A prominent Hindu astrophysicist suggested that 3I Atlas might represent a physical manifestation of consciousness transcending conventional boundaries, a concept resonant with certain Vedantic traditions. These varied religious responses shared a common theme, an attempt to place the unknown visitor within frameworks that could provide meaning and context for human observers. Sacred texts had always whispered of greater skies than we could see. Among the scientific community, a vigorous debate emerged about observation protocols and potential contact scenarios. Some scientists, led by Dr. Maria Santos of the SETI Institute, advocated for active attempts to communicate with 3I Atlas through directed radio signals or laser pulses. If there's even a small possibility that this object represents extraterrestrial technology, she argued, we have a scientific and perhaps moral obligation to attempt communication. Others, including Dr. Youssef Al-Fahim of the International Astronomical Union, urged caution. We're dealing with an unknown entity that has already demonstrated unexplained behaviors. Until we better understand its nature, active contact attempts could be premature or potentially problematic. This debate extended beyond scientific circles into governance structures, with the United Nations Security Council holding closed-door sessions to discuss potential protocols should evidence of artificial origin become more compelling. Beneath the scientific discourse lay a deeper question. Were we ready to listen if something answered back? A parallel conversation unfolded about the philosophical implications of Three-Eye Atlas, regardless of its ultimate nature. Dr. Helena Vassiliev, philosopher of science at Oxford University, published an influential essay titled The Visitor as Mirror, arguing that our collective response to Three-Eye Atlas revealed more about human consciousness than about the object itself. We project meaning onto the cosmos, she wrote, and in that projection, discover aspects of ourselves previously hidden from view. Whatever Three-Eye Atlas may be in itself, it functions as a mirror reflecting our deepest concerns about our place in the universe, our fear of cosmic loneliness, and our hope for connection beyond the boundaries of our world. Her essay inspired discussions across disciplines about how encounters with the truly unknown shape human self-understanding. The visitor had not yet spoken, yet we heard echoes of ourselves in its silence. We projected our deepest questions onto its silent form, and in that projection, found each other. As Three-Eye Atlas faded beyond Earth's sight, traveling onward toward interstellar space, scientists turned inward again. They began to study not the sky, but the magnetic pulse it left. Faint traces recorded deep within the planet's own field, signatures preserved in the subtle flux of electromagnetic energy that surrounds our world. Earth's magnetosphere had registered the passage like a sensitive instrument, vibrating in subtle ways that continued long after the object had moved beyond detection range. These vibrations weren't random disturbances, but coherent patterns, rhythmic fluctuations that persisted for weeks, gradually diminishing in amplitude but maintaining their essential structure. Geophysicists at stations from Antarctica to the Arctic documented these lingering effects, harmonic oscillations that seemed to resonate with the planet's natural frequency, as if the visitor had somehow found the precise note that made Earth sing. The phenomenon resembled how a tuning fork will cause another tuning fork of the same frequency to vibrate sympathetically, even without direct contact. Earth had listened and responded. Like ripples continuing to move across a pond, long after the stone that created them has sunk to the bottom, these magnetic echoes suggested a form of communication more fundamental than radio waves or light signals. The phenomenon prompted new research into planetary electromagnetic fields as potential communication mediums across vast distances. Dr. Yumi Tanaka at the University of Tokyo proposed a radical hypothesis that attracted both ridicule and serious consideration. What if planets themselves could send and receive information through magnetic pulses? What if Earth had been engaged in such exchanges for billions of years, a conversation too slow and subtle for its brief-lived human inhabitants to notice? She pointed to unexplained anomalies in Earth's paleomagnetic record, strange fluctuations preserved in magnetized minerals that didn't correspond to known geological processes or solar events. Perhaps, she suggested, these are not anomalies at all, but messages, the fossilized remains of conversations that occurred long before humanity emerged. Dr. Tanaka proposed that certain unexplained magnetic anomalies in Earth's geological record might represent traces of previous cosmic encounters, preserved like fossil footprints in the planet's electromagnetic history. Maybe the cosmos isn't out there. Maybe it's beneath us, waiting to be remembered in the very iron of our blood, the electrical impulses of our thoughts, the magnetic fields generated by our beating hearts. Maybe we are not just observers of cosmic phenomena, but participants in them, carriers of ancient information encoded not in our DNA, but in the subtle electromagnetic patterns that our bodies generate and respond to without our conscious awareness. The planet remembered what our instruments could not capture. Dr. Tanaka's controversial hypothesis inspired a surge of research into Earth's magnetic field and its potential as an information carrier. Teams at magnetic observatories in Greenland, Siberia, and Antarctica began combing through decades of archived data, searching for patterns similar to those left by Three-Eye Atlas. The European Space Agency redirected 3 satellites equipped with magnetometers to focus on measuring subtle fluctuations in Earth's field, creating the most detailed magnetic map of our planet ever assembled. "We're looking for whispers in a hurricane," explained Dr. Martin Schaefer, head of ESA's Geomagnetism Division. The challenge is distinguishing potential signals from the natural background noise of a geologically and atmospherically active planet. Ancient songs might have been playing beneath our feet all along, their melodies lost in Earth's magnetic hum. The magnetic patterns left by 3I Atlas displayed several properties that challenged conventional understanding. First, they persisted far longer than mathematical models predicted they should, maintaining coherence for weeks rather than dispersing within hours as typical magnetic disturbances do. Second, they exhibited self-reinforcing properties, actually increasing in strength and organization during the first 72 hours after 3I Atlas's closest approach before beginning a slow decay. Third, they showed resonant characteristics specifically tuned to the natural frequency of Earth's magnetosphere, the same frequency at which the planet's magnetic field normally oscillates, due to the interaction between the core's dynamo effect and solar wind pressures. As Dr. Wei Chang of Berkeley's Earth Sciences Department noted, it's as if the visitor knew exactly which frequency would create maximum resonance with our planet's natural systems. That's either an extraordinary coincidence or suggests a level of interaction we don't yet understand. Like a finger touching water, the visitor had set our world vibrating at its deepest levels. Neurophysiologists noticed another curious phenomenon in the weeks following 3I Atlas's passage: subtle but measurable changes in human brain activity corresponding to the magnetic fluctuations. Dr. Sophia Martinez at Johns Hopkins Medical Center had been conducting routine EEG studies when her team noticed unusual synchronization patterns across multiple subjects. We observed increased coherence in alpha and theta wave activity that correlated precisely with the peaks in the planetary magnetic resonance patterns, she reported. It's as if the human brain was somehow detecting and responding to these subtle field changes. Her findings sparked collaborations between neuroscientists and geophysicists exploring the potential biological impacts of the magnetic phenomena. While some dismissed the correlations as coincidental or the result of heightened public interest in the visitor, others pointed to established research showing that human neural activity can be influenced by electromagnetic fields. Our neural networks dance to rhythms we couldn't consciously hear. Researchers studying animal behavior reported similar anomalies, unusual. Migration patterns in birds and marine mammals, synchronized behaviors among insect colonies, and altered circadian rhythms in laboratory animals. Dr. Rachel Okoye at the University of Cape Town documented how African elephants across multiple reserves simultaneously oriented themselves toward the area of sky where 3I Atlas had been visible, maintaining this orientation for hours, even when the object was below the horizon. Many species possess magnetoreception capabilities far more sensitive than our own, she noted. They may be perceiving aspects of this phenomenon that our instruments barely detect. Her research raised questions about whether Earth's biosphere might function as a complex sensing network for cosmic phenomena, a planetary nervous system of sorts, with different species sensitive to different aspects of electromagnetic variation. The animals knew something had changed. In the world's invisible currents, Dr. Tanaka's research team focused on geological records that might preserve evidence of previous magnetic anomalies, similar to those created by 3I Atlas. They examined magnetized minerals in ancient rock formations, searching for signature patterns that might indicate past cosmic encounters. In sedimentary layers dating back 73 million years, they discovered magnetic alignments that showed striking similarities to the current phenomenon, organized patterns that stood out from the background noise of Earth's normal field variations. Similar patterns appeared in samples from approximately 255 million years ago, and again around 415 million years ago. These could represent natural field fluctuations with causes we haven't identified, Dr. Tanaka acknowledged. But the statistical similarity to the 3I Atlas signature is compelling enough to warrant further investigation. Her team began collaborating with paleontologists to determine whether these magnetic anomalies coincided with evolutionary transitions or other significant biological events. The rocks held memories of visitors long before humans raised their eyes to the stars. Engineers at several research institutions began developing technologies based on insights gained from studying the magnetic resonance patterns. Dr. Jamal Ibrahim at MIT created prototype sensors that could detect and amplify the subtle magnetic signatures left by 3I Atlas, potentially allowing for more sensitive monitoring of Earth's magnetosphere. At the Chinese Academy of Sciences, a team led by Dr. Lin Wei explored potential applications for long-distance communication using modulated magnetic fields tuned to planetary resonance frequencies. If these patterns can maintain coherence over weeks, despite the chaotic nature of Earth's magnetic environment, Dr. Lin explained, they might offer a novel approach to signal propagation that's more robust than conventional electromagnetic transmission methods. The visitor's echo became the blueprint for technologies we had never imagined. The most controversial research direction emerged from Dr. Elena Volkov's laboratory at the Russian Academy of Sciences, where her team attempted to artificially reproduce the 3I Atlas magnetic signature. Using a network of precisely calibrated electromagnetic generators positioned around the globe, they created a scaled version of the pattern and introduced it into Earth's magnetosphere. Initial results suggested that these artificial signals maintained coherence longer than control patterns designed without reference to the visitor's signature. "We're learning to speak in a language we've only just discovered," Dr. Volkov told colleagues at an international conference. "Whether anyone is listening remains unknown, but we're developing the grammar of a potential cosmic dialogue." Her work divided the scientific community, with some praising the innovative approach, while others expressed concern about broadcasting signals modeled after an unknown cosmic phenomenon. We were learning to echo back into the void, hoping something might answer. Every heartbeat carries the echo of stars that died to create the iron in our blood. Weeks later, telescopes tracking 3I Atlas at the edge of their capacity noticed something unexpected, a reflection pattern diverging from the object, as if sunlight had been refracted intentionally, signaling into the void. Using advanced image processing techniques to enhance the faint signal, astronomers observed what appeared to be directional light emissions, beams of focused radiation directed not toward Earth, but toward a point in the constellation Cygnus. The pattern appeared too structured for random reflection, too precise to dismiss as instrumental error. It showed geometric properties that suggested deliberate formation, concentrations of light in specific wavelengths arranged in patterns that repeated with mathematical precision. Perhaps a coincidence of crystalline formations catching the sun at particular angles, creating natural prism effects that concentrated light in specific directions. Perhaps not. Light travels in straight lines, but 3I Atlas seemed to prefer curves, bending illumination in ways that created momentary geometric patterns visible only from certain observational perspectives. These patterns appeared and disappeared as the object rotated, creating something like a lighthouse effect, brief flashes of structured light separated by periods of darkness. "It's as if it knows exactly where we're looking from," noted a graduate student at the Very Large Array in New Mexico, a comment that earned both nervous laughter and thoughtful silence from senior colleagues monitoring the anomalous signals. The patterns continued for several days before ceasing abruptly, leaving researchers with hours of recorded data, but few conclusions about what they had witnessed. When analyzed, the light variations formed sequences that mathematicians found intriguingly non-random, exhibiting properties consistent with information-carrying signals rather than natural phenomena. No definitive meaning could be extracted from these patterns, yet they resisted classification as mere noise or coincidence. And in those gentle bends of light, we saw a question we weren't ready to answer, a query written in photons and shadow that seemed to ask, "Are you watching? Do you understand what you're seeing? Are you ready to join a conversation that began long before your star ignited?" The question wasn't addressed to governments or scientific institutions, but to consciousness itself, to whatever within us might recognize something kindred in these patterns from beyond. We weren't the only ones watching. We were being watched in return. The light patterns emanating from 3I Atlas became the subject of intensive analysis at observatories worldwide. Dr. Astrid Johansson at the European Southern Observatory In Chile led efforts to categorize the emissions according to wavelength, duration, directionality, and sequential structure. Her team identified 7 distinct pattern types, each with characteristic properties that repeated with variations throughout the observation period. What's particularly interesting, she noted, is that these patterns show both mathematical consistency and what appears to be intentional variation, similar to how a musician might play variations on a central theme. The patterns predominantly used wavelengths in the visible spectrum, with particular emphasis on blue, green, and near-ultraviolet frequencies, the same ranges most easily detected by observatories on Earth. The light spoke in cadences too ordered for chance, too strange for certainty. Mathematicians from the Santa Fe Institute conducted complex statistical analyses of the pattern sequences, searching for internal structure that might suggest meaning. Dr. Robert Chen's team applied information theory principles to determine whether the signals contained the hallmarks of structured communication. What we found is fascinating, Dr. Chen reported. The light patterns exhibit what we call optimal encoding density. They contain exactly the right balance of regularity and surprise that characterizes efficient information transfer. Natural phenomena typically show either too much regularity or too much randomness to efficiently encode complex information. His analysis suggested that if the patterns were indeed signals, they represented an extraordinarily efficient communication system, potentially capable of transmitting vast amounts of information through minimal variations. The mathematics revealed a whisper of impossible efficiency across the void. Particularly intriguing was the directional nature of the emissions. While 3I Atlas was under observation from Earth, the light patterns were consistently directed toward a specific point in the constellation Cygnus, specifically toward the region containing Kepler 452, a star system approximately 1/800 light-years away, known to harbor at least one potentially habitable exoplanet. The directional precision is remarkable, noted Dr. Maria Valdez at NASA's Jet Propulsion Laboratory, even accounting for the motion of both our solar system and the Kepler 452 system through space. The emissions remain targeted with an accuracy that would require either extraordinary coincidence or sophisticated positional calculation. Her team estimated that maintaining such directional precision would require knowledge of stellar positions and movements accurate to within 0.001 arcseconds, a level of astronomical precision exceeding our own current capabilities. Across nearly 2,000 light-years of darkness, something was threading a needle with light. The timing of the light emissions added another layer of mystery. They began precisely 127 hours after 3I Atlas reached its closest approach to Earth, continued for exactly 88 hours, then ceased completely. Both numbers, 127 and 88, are prime numbers, a fact that mathematicians found suggestive though not conclusive. Prime numbers have been proposed as potential communication markers in SETI protocols, explained Dr. Ahmed Hassan of Princeton's mathematics department. They're mathematically significant across any number system based on counting, making them potential universal signifiers of intelligent communication. More curious still, the total duration in seconds, 16T800, corresponds precisely to the time required for light to travel from Earth to the region of Cygnus, where the signals were directed. Time itself became a message, measured in seconds and light-years optical. Physicists studying the emission mechanisms proposed several theories about how 3I Atlas might be generating these structured light patterns. Dr. Jin Park of Seoul National University suggested that the object might possess surface materials with unusual photonic properties, structures that could manipulate light through processes similar to those found in natural opals or butterfly wings, but far more sophisticated. What we might be observing, he theorized, is a form of responsive metamaterial that can dynamically alter its optical properties in reaction to incoming radiation. Other researchers proposed that the object might contain internal chambers functioning as optical resonators, creating complex interference patterns that manifested as the observed emissions. Like a celestial prism, it transformed our sun's light into patterns that defied understanding. The scientific community remained divided about whether the light patterns represented intentional communication. Dr. Eliza Hammond of Caltech urged caution. We must remember that human perception is primed to recognize patterns even in random phenomena. What appears to us as structured signals might be natural optical effects we simply haven't encountered before. Others, including Dr. Victor Okafor of Nigeria's National Space Research and Development Agency, argued that the cumulative evidence suggested purpose. When we consider the directional precision, mathematical structure, timing, and wavelength selection together, he wrote, the probability of natural origin becomes increasingly difficult to defend. At some point, we must consider the possibility that we are observing deliberate activity. Our certainties dissolved in the space between coincidence and communication as the light pattern ceased and Three-Eyes Atlas continued its journey out of our solar system. Radio astronomers focused their attention on the region of Cygnus toward which the emissions had been directed. The Green Bank Telescope, the Allen Telescope Array, and China's Fast Radio Telescope coordinated efforts to monitor that sector for potential responses. If 3A Atlas was indeed sending a message toward Kepler 452, we might detect a reply, though given the distance, any response would take approximately 3,600 years to complete the round trip, explained Dr. Sarah Mitchell of the SETI Institute. More likely, we're observing one segment of an ongoing conversation that began long before we were listening and will continue long after we've forgotten how to hear. In the ancient rhythm of stellar conversations, we had glimpsed a single syllable. Sometimes questions travel across galaxies before finding someone ready to hear them. Some cultures began to treat the event as a cosmic omen, not of doom, but of awakening. Indigenous skywatchers from Australia to the Americas incorporated Three-Eye Atlas into their celestial traditions, seeing in its passage a fulfillment of ancient stories about messengers from the star ancestors. The Maori spoke of Matariki returning in unexpected form. Aboriginal elders in Australia's Northern Territory identified the visitor with ancestral beings from the Dreamtime who travelled between stars. Navajo skywatchers saw in it the return of Black God, who placed the constellations in the night sky. These interpretations weren't primitive, misunderstandings but sophisticated, cultural frameworks for integrating cosmic phenomena into human experience, frameworks that had evolved over thousands of years of careful observation. New spiritual movements emerged alongside these traditional interpretations, centered around the idea of cosmic connection and interstellar consciousness. Meditation groups gathered in desert locations and mountain retreats, attempting to attune to the visitor's frequency. They said the stars dream through travelers like this, letting the universe remember itself for a moment. That objects like Three-Eye Atlas serve as bridges between isolated worlds, carrying not physical messages but resonant frequencies that trigger evolutionary leaps in consciousness. That what appeared to be a rock moving through space might actually be a thought moving through time, an idea propagating across the cosmos like a wave, touching different shores of awareness as it passed. Science had no words for such concepts, no instruments to measure cosmic consciousness or interstellar telepathy. Yet even scientists stayed longer under the night sky that week, gazing upward with questions that transcended their professional training. Dr. Ibrahim Hassan, a noted skeptic and debunker of pseudoscientific claims, who had built his career on rigorous materialist explanations, was observed sitting alone on the roof of the observatory in Arizona long after his shift ended. When a colleague asked why, he simply replied, "Because something listened when we watched it. I don't know what that means yet." Maybe knowledge is just another form of remembering, a recognition of patterns that have always existed, waiting for us to evolve the capacity to perceive them. Maybe what we call discovery is actually recollection, the gradual awakening to truths encoded in the structure of reality itself, accessible when consciousness reaches the necessary level of complexity to receive them. The oldest stories recognized what our newest instruments could barely detect. Among the Aboriginal communities of Australia's Northern Territory, elders gathered to discuss the significance of the visitor through traditional Dreamtime frameworks. Warramungu elder Japananka Martin explained to anthropologists documenting these interpretations. "This one we've been waiting for him. Old people tell story about the travelling stone that comes to remind us about star country. He moves between worlds carrying messages from ancestors. In these traditions, the appearance of Three-Eye Atlas was not unexpected, but foretold. A cosmic event that occurred cyclically across vast timescales, connecting present observers with ancestral knowledge. Community gatherings included ceremonial painting and song cycles specifically related to celestial visitors. Traditions that elders insisted had been performed for thousands of years whenever certain signs appeared in the sky. Ancient songs awakened to greet a visitor they had always expected. In New Zealand, Maori astronomers integrated observations of Three-Eye Atlas with traditional knowledge about Matariki, the Pleiades star cluster, whose appearance marks the beginning of the new year in Maori tradition. Dr. Rangi Thompson, who holds positions at both Auckland University and as a cultural advisor to several Maori tribes, described how traditional star lore included references to travelers or messengers associated with Matariki. Our ancestors understood that the cosmos is dynamic and communicative, he explained. The stories speak of objects that move between star systems, carrying knowledge or warnings. What science sees as a new discovery, our traditions recognize as part of an ongoing cosmic conversation. Several Maori communities held special ceremonies at traditional observatories, places where alignments of stones and earthworks had been used for astronomical observations for centuries. Their ancestors had left instructions for this very moment, preserved in stone and story. Indigenous perspectives gained unprecedented attention in scientific and media discussions of Three-Eye Atlas, highlighting how traditional knowledge systems often contained sophisticated astronomical observations embedded within cultural frameworks. Dr. Gabriela Ramirez, an ethno-astronomer working with Quechua communities in Peru, documented how Andean traditions included detailed observations of unusual celestial phenomena, preserved in woven textiles, architectural alignments, and oral histories. What we're seeing is a convergence of knowledge systems, she noted. Western science is beginning to recognize that indigenous traditions often contain accurate astronomical observations spanning thousands of years, recorded through cultural methods rather than written documents. The libraries of stars had always had many readers, speaking different languages. New spiritual movements formed in response to Three-Eye Atlas, distinct from traditional religious interpretations. The largest of these, calling itself Cosmic Resonance, grew from informal meditation groups into an international network with tens of thousands of participants. Founded by former astrophysicist Dr. Maya Sullivan, the movement focused on the idea that consciousness itself might be the primary medium of cosmic communication. What if the messages from Three-Eye Atlas aren't encoded in radio waves or light patterns, but in subtle influences on consciousness itself? Sullivan proposed. Perhaps the visitor's purpose is to trigger a shift in human awareness, to help us remember our connection to the larger cosmos. The movement organized synchronized global meditation, events timed to coincide with significant astronomical alignments, attempting to establish what Sullivan called coherent fields of consciousness that might be detectable across interstellar distances. Some believed the true telescope was consciousness itself, focused through collective attention. Established religions responded to Three-Eye Atlas with varying degrees of integration into existing theological frameworks. The Vatican Observatory, staffed by Jesuit astronomers, published a statement emphasizing that potential extraterrestrial intelligence posed no challenge to Catholic theology. The vastness of God's creation has always been understood to potentially include other worlds and other beings, noted Father Giuseppe Bertelli, the observatory's director. The question is not whether such existence would challenge our faith, but how such existence might expand our understanding of God's creative work. Islamic scholars pointed to Quranic verses that specifically mentioned God's creation of worlds in the plural form, suggesting that the divine plan had always included the possibility of life beyond Earth. Sacred texts unfolded new meanings beneath the light of distant stars. Art inspired by Three-Eye Atlas flourished across media and cultural contexts. Chinese filmmaker Zhang Wei created Visitor, an experimental film juxtaposing telescopic imagery of the object with scenes of daily life transformed by awareness of cosmic connection. Nigerian author Chinwe Okafor published Messengers, a novel exploring how an interstellar visitor might be interpreted through various African cosmological frameworks. Composer Hiroshi Tanaka's symphony Interstellar Passage incorporated mathematical patterns derived from 3I Atlas's light emissions into its melodic structure. The Guggenheim Museum in New York organized Cosmic Dialogues, an exhibition featuring artistic responses to the visitor from contemporary artists worldwide. These creative interpretations often bridged scientific observation and emotional response in ways that pure data could not, offering metaphorical languages for experiences that defied literal description. Art became the translator of mysteries science could only observe. Public education about astronomy and space science experienced unprecedented growth during the 3I Atlas period. Enrollment in astronomy courses doubled at universities worldwide. Amateur telescope sales increased by 300%. Mobile applications offering real-time tracking of the visitor were downloaded more than 40 million times. Science museums extended hours to accommodate crowds eager to view exhibitions about interstellar objects. A global citizen science project, coordinated by the Planetary Society, engaged millions of volunteers in analyzing observational data. We're witnessing perhaps the greatest public engagement with astronomy in human history, noted Dr. Fatima Al-Zahra, Director of Science Education at UNESCO. Whatever 3I Atlas may ultimately represent scientifically, its cultural impact has already transformed humanity's relationship with the cosmos. A single visitor had awakened millions of eyes to the night sky. Even as public fascination with 3I Atlas grew, the experience remained deeply personal for many observers. Countless people reported profound emotional responses to viewing the visitor, often describing feelings of connection, perspective shift, or existential awareness that transcended scientific understanding. Dr. Elena Mikhailova, a psychologist studying these responses, noted common themes across cultural backgrounds. Many people describe a dissolution of boundaries between self and cosmos, a sense of recognition or remembrance, as if the visitor had activated something already present within human consciousness. These experiences bear striking similarities to what religious traditions have called mystical awareness and what some neuroscientists now describe as non-dual consciousness, a state in which the perception of separation between observer and observed temporarily dissolves. In the silence between thoughts, something ancient stirred to wakefulness. Perhaps revelation is just remembrance in another form. A month later, something strange began happening in research facilities around the world. Archived recordings of 3I Atlas's passage began to show corruption. Digital files vanished from secured servers or overwrote themselves with static. Raw data collected from radio telescopes, spectrographic analyses, optical observations all showed degradation that data forensic specialists couldn't explain through normal electronic failure or software glitches. Not maliciously as if hacked, but as if the data had decayed too fast, like flowers that bloom for a single night before returning to the soil. Information seemed to be reorganizing itself, dissolving not into random noise, but into structured patterns that themselves defied analysis. Backup systems showed similar degradation, even those stored in electromagnetic isolation. The corruption spread across different media types, from digital storage to printed materials, where ink seemed to fade in specific patterns rather than uniformly. Images blurred in specific patterns that data recovery specialists found non-consistent with standard digital entropy, as if the degradation itself carried information. Like a message written in the process of erasure, it was as if the memory of the event refused to stay fixed, refused to be catalogued and analyzed according to human methodologies. The few recordings that remained intact showed subtle differences from their original versions, changes in light patterns, variations in spectroscopic readings that hadn't been present in initial observations. When comparing notes, researchers found contradictions in their data that couldn't be attributed to equipment, differences or methodological variations, as if 3I Atlas had somehow existed in slightly different states for different observers. Dr. Lisa Chen at MIT suggested that perhaps certain types of information resist permanent capture, existing in states of quantum uncertainty. that collapse differently each time they're observed. Maybe we're dealing with a phenomenon that exists partially outside our normal reference frame, she proposed in a theoretical paper that sparked heated debate. Something that intersects with our reality, but isn't fully contained by it. Like trying to photograph a dream, the act of observation itself seemed to alter what was being observed, creating a kind of uncertainty principle that operated not just at quantum scales, but at the macroscopic level where human perception functions. Some things are not meant to be kept, only felt once perfectly in the moment of their happening. Perhaps 3i Atlas existed most truthfully, not in our instruments and databases, but in the imperfect human memories of those who witnessed its silent passage, memories that, like the visitor itself, would continue to evolve and transform long after the event had passed beyond observation. Even as we tried to hold it, it slipped through our digital fingers like starlight through leaves. The pattern of data degradation itself became the subject of intense study. Dr. Marcus Kaufman, a specialist in information theory at Stanford University, analyzed the corruption patterns across multiple data repositories. "What we're seeing isn't random decay," he reported to a hastily assembled conference of concerned researchers. "The information isn't simply being lost. It's being transformed in consistent ways across physically isolated systems. The probability of this occurring through conventional data corruption mechanisms is effectively zero." His team identified mathematical similarities between the corruption patterns and the light emissions previously observed from 3i Atlas, suggesting a connection between the two phenomena. The corruption appeared to follow something resembling a fractal pattern, self-similar at different scales of analysis, with small-scale corruptions reflecting the structure of larger patterns. The data wasn't dying, it was evolving into forms beyond our comprehension. Computer security experts initially suspected coordinated cyber attacks, but investigations revealed no evidence of external intrusion into the affected systems. Many of the corrupted datasets were stored on air-gapped computers with no network connection, making conventional hacking impossible. Dr. Nadia Petrova of Russia's Cybernetic Security Institute conducted forensic analyses of affected systems and found no malware signatures, unusual access patterns, or other indicators of security breach. "Whatever is happening to this data," she concluded, "it appears to originate within the data itself, as if the information contains some form of self-modifying property that our storage systems cannot stabilize." This finding prompted research into novel data, integrity verification methods, and storage, technologies that might preserve the unstable information. The visitor's memory refused to be confined in our digital cages. Dr. Chen's quantum uncertainty hypothesis gained support from theoretical physicists studying the boundaries between quantum and classical systems. Dr. James Wu of Caltech proposed that 3i Atlas might represent a macroscopic quantum object, something that maintained quantum properties at scales where such behaviors are typically suppressed by environmental interaction. Quantum systems resist definitive measurement, he explained. They exist in superpositions of multiple states until observed, at which point they collapse into a single state. If 3i Atlas somehow maintained quantum coherence at a macroscopic scale, our observations may have triggered partial state collapses that continue to resolve in unexpected ways, including in the data we collected. His theory suggested that the corrupting information might represent aspects of the object that existed in quantum superposition during observation, continuing to evolve even after being recorded. Reality itself seemed to shimmer and shift around the memory of what we had seen. The Perimeter Institute for Theoretical Physics in Canada convened a special research group to explore connections between 3i Atlas and emerging theories of quantum gravity. Dr. Sofia Mendez suggested that the data corruption might represent a previously unobserved phenomenon at the intersection of quantum mechanics and general relativity, theoretical frameworks that have proven difficult to reconcile. We may be observing effects related to information preservation across different reference frames, she proposed. If 3i Atlas originated from or passed through regions of spacetime with different physical properties than our local environment, the information associated with it might be fundamentally incompatible. with our physical information storage systems. Her team developed mathematical models attempting to describe how information might transform when moving between different gravitational or quantum regimes. The visitor had brought fragments of physics from realms where our rules dissolve. While digital records degraded, human memories of the event showed curious stability, and in some cases, enhancement. Dr. Takashi Yamamoto, a cognitive neuroscientist at Kyoto University, conducted studies comparing people's recollections of 3I Atlas observations with documented records before corruption occurred. Surprisingly, test subjects maintain more accurate and detailed memories of the event than would be expected based on standard models of memory formation and decay, he reported. In some cases, individuals recall details that match original data records but were lost in subsequent corruption. Even more intriguingly, brain scans of subjects recalling their observations showed unusual activity, patterns, heightened synchronization across normally distinct neural networks, and activation of brain regions typically associated with direct perception rather than memory recall. Our neurons preserved what our computers could, not echoes of something vast and strange. Some researchers proposed that the data corruption might represent an aspect of information physics that current theory hadn't yet incorporated. Dr. Elena Vasilyev of Moscow State University suggested that certain types of information might have intrinsic decay rates independent of their storage medium, a kind of half-life for information itself. Perhaps what we're observing is a natural process, whereby information about certain phenomena becomes inherently unstable once removed from its source, she theorized. Not because of any failure in our recording methods, but because that information has properties we haven't accounted for in our models of data. Preservation. Her team began developing experiments to test whether other types of astronomical observations might show similar, if less dramatic, signs of inherent information decay. Some truths may be too wild to be captured and caged in human systems. By early January, research teams worldwide had implemented extraordinary measures to preserve what data remained. The European Space Agency established a dedicated lunar archive facility, reasoning that the Moon's stable environment and distance from Earth might provide better preservation conditions. The Chinese Academy of Sciences developed a novel storage method using synthetic DNA encoded with the observational data, stored in multiple redundant copies. The Internet Archive created a distributed backup system, with copies maintained by thousands of volunteers worldwide, hoping that widespread replication might slow the corruption process. Despite these efforts, the degradation continued, slower in some storage formats than others, but persistent across all known methods of information preservation, like trying to hold water in a sieve. We struggle to keep what was determined to return to mystery. Some truths can only be carried in the fragile vessels of human memory. By February, 3I Atlas had vanished from all instruments. No trace remained visible to even our most powerful telescopes. No signal detected by radio arrays, straining to catch some final whisper. No echo returned from radar pulses, sent toward its last known position. No visible reflection caught the distant sunlight as it retreated into the cosmic night from which it had emerged. The visitor had slipped beyond our technological grasp, returning to the vast darkness between stars from which it had emerged. Just an expanding field of calm remained, as if the universe had exhaled after holding its breath during our brief encounter. The object's departure created a curious emptiness, not just in the data streams and observation schedules, but in the collective consciousness that had briefly unified around this cosmic enigma. Whatever it was, natural phenomenon, ancient artifact, or something beyond our current understanding, it had passed through us and gone home to wherever home is for something born between stars. Perhaps back to the interstellar void, where radiation and temperature approach absolute zero, where time itself seems to slow in the absence of change, where patience becomes not a virtue, but a state of being. Perhaps to another star system, carrying whatever it learned from our brief encounter to some other world where consciousness has evolved to look upward and wonder. Astronomers would continue to analyze the fragmentary data for years to come, building careers around competing interpretations of what 3I Atlas had been. Papers would be published, conferences organized, theoretical models constructed and debated. But the object itself had returned to mystery, carrying whatever secrets it possessed back into the cosmic ocean. Perhaps that was its purpose all along, not to be captured and understood, but to remind us of how vast the unknown remains, how limited our perception, how brief our moment in the grand sweep of cosmic time. To show us not answers, but better questions, questions that might guide our species toward greater humility and wonder as we continue our own journey through the galaxy. The absence it left felt deeper than the presence it had been. In its final days of visibility, 3I Atlas performed one last unexpected maneuver. As it passed the orbit of Neptune, astronomical observatories detected a slight but definitive change in its trajectory, a gentle curve that adjusted its course by approximately 0.5 degrees. This subtle shift would, over cosmic distances, direct it toward the star system HD 162826, a sun-like star approximately 110 light-years away. Astrophysicists calculated that, maintaining its current velocity, 3I Atlas would reach the vicinity of HD 162826 in approximately 1.3 million years. "It's as if it's navigating," remarked Dr. Elena Kuznetsov of Russia's Pulkovo Observatory. "Each course adjustment we've observed appears calibrated to direct it toward specific stellar destinations, suggesting either an extraordinary series of coincidences or some form of intended transit between star systems. The precision of these adjustments, occurring without any detectable propulsion mechanism, remained one of the most puzzling aspects of the visitor's behavior. Like a sailor reading celestial charts, it had chosen its next harbor among the stars. The final optical observations of 3I Atlas, captured by the Hubble Space Telescope before the object faded beyond detection range, revealed one more anomaly. The visitor's albedo, its surface reflectivity, changed dramatically during its last visible hours, dropping from approximately 0.35, similar to many asteroids, to less than 0.05, darker than coal. This change occurred uniformly across its surface, rather than in patches, as if the entire object had suddenly absorbed rather than reflected incoming light. "It's as if it put on a cloak of darkness," noted Dr. Michael Chen of Johns Hopkins University. "This kind of uniform change in surface properties isn't consistent with any natural process we understand." Some researchers suggested the change might represent a final phase of whatever natural cycle the object followed, while others speculated about more exotic possibilities: adaptive camouflage, energy absorption, or transition to a state less detectable to Earth-based observation technologies. In its final moment before the cosmic curtain, it wrapped itself in darkness and slipped away. As direct observation became impossible, astronomers continued tracking the space where 3I Atlas should be, searching for any lingering effects of its passage. Dr. Sarah Williams at the Green Bank Observatory led efforts to detect potential gravitational influences on Kuiper belt objects along the visitor's projected path. "Even if we can't see it directly," she explained, "its gravity should still affect smaller objects it passes near. By observing these secondary effects, we might track its progress long after direct visibility ends." Her team calculated that such observations might extend our ability to monitor 3I Atlas for another 15 to 20 years, though with decreasing precision as the visitor moved farther from known reference objects. The effort represented a new approach to astronomical tracking, focusing on absences and influences rather than direct detection, like tracking a ghost by the curtains it moves. We sought the visitor's invisible hand. The scientific community began the long process of integrating the 3I Atlas observations into broader astronomical understanding. Dr. James Chen at Princeton University led efforts to create new classification systems for interstellar objects, with 3I Atlas representing a potentially new category distinct from previous visitors like Oumuamua and Borisov. "What we're developing," he explained, "is a taxonomy of cosmic travelers, a framework for understanding the diverse objects that move between star systems." His work highlighted how little we understood about interstellar space and its contents, suggesting that objects like 3I Atlas might be relatively common, but rarely detected due to technological limitations and the vastness of space. Future telescope projects, including the Vera C. Rubin Observatory and the Nancy Grace Roman Space Telescope, incorporated specific observation protocols designed to identify similar objects earlier. In their solar system approaches, each visitor taught us to look more carefully into the darkness between stars. Beyond astronomy, the 3I Atlas encounter catalyzed new interdisciplinary research initiatives. The European Union established the Interstellar Phenomena Research Consortium, bringing together physicists, information theorists, biologists, and consciousness researchers to explore the broader implications of the visitor's passage. NASA and China's space agency announced a joint mission concept for an interstellar probe designed to study the regions through which 3I Atlas had traveled, potentially launching within the next decade. The United Nations formed a permanent committee for interstellar object monitoring and response, creating protocols for international scientific collaboration during future encounters. What 3I Atlas revealed, noted Dr. Fatima Al-Zahra in her address to the committee's inaugural session, is that we were scientifically, philosophically, and perhaps psychologically unprepared for even this brief contact with something truly outside our system. The next visitor may find us better equipped to understand what we observe. We began building bridges toward horizons we once thought unreachable. As technical observation ended, philosophical reflection intensified. The Journal of Cosmological Philosophy dedicated a special issue to essays exploring the implications of the 3I Atlas encounter for human understanding of our place in the universe. Contributors from diverse cultural and intellectual traditions addressed questions raised by the visitor's passage. How should we understand phenomena that resist categorization within our existing scientific frameworks? What does it mean for human consciousness to encounter potential non-human intelligence or intention? How do we integrate experiences at the boundary of comprehension into our collective worldview? Dr. Helena Vassiliev's contribution, The Ethics of Cosmic Uncertainty, argued that experiences like the 3I Atlas encounter required a new philosophical approach, one that embraced uncertainty not as a temporary state before knowledge, but as a fundamental condition of cosmic citizenship. Perhaps wisdom begins not in knowing, but in understanding the vastness of what we cannot know. Poet laureate Maya Winters captured the emotional impact of the visitor's departure in her widely shared poem After Passage, which concluded, "The stars remain precisely where they were, yet everything has shifted. We stand in the same rooms on the same earth, but with windows opened onto vaster skies than we had known existed." Her words resonated with millions who felt both the wonder and the melancholy of the visitor's departure. A beau seat I sense that something significant had briefly touched human awareness before returning to regions beyond our reach. The poem became part of school curricula worldwide, translated into over 100 languages, often paired with astronomical images of 3I Atlas in cultural archives preserving the event. Its wake left ripples in our dreams, echoes in our poetry, questions in our science. All visitors eventually leave, but the doorways they open remain. Years from now, 3I Atlas will be nothing more than a name in quiet databases, a reference in astronomy textbooks, a footnote in the ongoing story of human cosmic discovery. Children yet unborn will learn about it alongside Oumuamua and Borisov as early examples of identified interstellar objects, perhaps wondering why such significance was attached to what might ultimately be explained as natural phenomena. New mysteries will capture our collective imagination, new anomalies in the cosmic background radiation, new exoplanets with unexpected atmospheric signatures, new mathematical solutions to old astronomical puzzles. New visitors may pass through our neighborhood, bringing their own questions and silences, their own patterns to decode or misinterpret. Yet some will remember that winter, the hush of the night, the strange beauty of not knowing, the sense of standing at the edge of comprehension. They'll tell stories that grow with each retelling, adding details that memory creates to fill the spaces left by fading certainty. They'll remember how for a brief moment, humanity looked upward together, united not by certainty but by wonder. How conversations in dozens of languages all ask the same essential question: Are we alone? How the visitor offered no clear answer, yet somehow made the universe feel less empty in its silence. How it passed through our world like thought passes through consciousness, leaving everything unchanged, yet somehow different. The sky forgets nothing. It holds every passing moment in its infinite depth, preserving in starlight all that has ever been. Each photon traveling outward carries the record of what it touched, what it illuminated, what witnessed its passage. And somewhere out there, beyond every telescope's reach, beyond the light of our sun, beyond perhaps even the edge of our galaxy, something is still looking back. Not with eyes as we understand them, but with whatever sense allows the cosmos to know itself through its countless parts. And in that quiet awareness, we are never truly forgotten. Our brief moment of consciousness preserved not in material record, but in the subtle alterations our existence makes to the fabric of reality itself. Ripples in space-time that continue outward forever. Touching distant shores we cannot imagine, the memory of stars outlives the light they cast. The 3I Atlas encounter transformed astronomical research priorities for decades to follow. In 2031, the Interstellar Object Detection Network became operational, a coordinated system of ground and space-based telescopes specifically designed to identify objects entering our solar system from interstellar space. Using advanced AI pattern recognition to analyze vast fields of observational data, the network could potentially identify incoming objects months or years earlier than previous detection methods, providing much longer observation windows. What 3I Atlas taught us, explained Dr. James Liu, the network's chief architect, is that we were looking at the sky with tools designed primarily for other purposes. By creating systems specifically attuned to detecting interstellar visitors, we dramatically increase our chances of early identification and comprehensive study. Within its first 5 years of operation, the network identified 7 additional interstellar objects, though none showed the anomalous properties that had made 3I Atlas so compelling. We had learned to watch the celestial doorways with patient, attentive eyes. Educational curricula worldwide integrated the 3I Atlas encounter into a broader framework for teaching cosmic perspective. Dr. Maria Gonzalez, who led development of UNESCO's Cosmic Citizenship Educational Initiative, explained the approach. We're using this encounter to help young people understand humanity's place in the universe, not as the center of things, but as participants in a vast cosmic community. Whether or not 3I Atlas represented intelligence as we understand it, the experience helps students grasp that we are not isolated, that our world is connected to others through the constant exchange of matter, energy, and potentially information across interstellar distances. The curriculum, adopted in 147 countries, combined astronomy, physics, philosophy, and cultural studies to foster what Gonzalez called cosmic consciousness, an awareness of connection to the larger universe that transcended national or terrestrial boundaries. The children of tomorrow would grow up knowing they were citizens of something greater than a single world. The scientific papers and theories about 3I Atlas multiplied in the years following its departure, creating what historian of science Dr. Jonathan Lee called a Rashomon effect in scientific literature, multiple, sometimes contradictory accounts of the same phenomenon, each supported by subsets of the fragmentary observational record. The Journal of Interstellar Studies, founded in 2028, dedicated its inaugural issue to competing interpretations of the visitor's nature and behavior. These ranged from conservative natural explanations, an unusually structured comet nucleus, a fragment of a shattered exoplanet, to more exotic proposals, a von Neumann probe, a quantum-entangled object manifesting simultaneously in multiple star systems, a biological entity adapted for interstellar travel. What makes the 3I Atlas case so fascinating, Dr. Lee noted, is not just the diversity of scientific interpretations, but how those interpretations reflect the theoretical frameworks and cultural assumptions of the researchers proposing them. It functions as a kind of scientific Rorschach test, revealing how different minds make meaning from the same mysterious phenomenon. The visitor had become a mirror, reflecting our own scientific imaginations. Artists continued to find inspiration in the 3I Atlas encounter long after its scientific prominence had faded. The visitor became a recurring motif in various art forms, a symbol of transience, mystery, possibility, or cosmic connection. Chinese director Zhang Wei's film trilogy, Passing Light, 2029-2035, used the Three-Eye Atlas encounter as a framework for exploring human relationships across vast distances and times. American composer Caroline Jackson's symphony Interstellar, 2032, incorporated mathematical patterns derived from the visitor's light emissions. Nigerian sculptor Adebayo Okafor's installation, Remembering Atlas 2034, used suspended reflective elements that created shifting light patterns as viewers moved through the space. What makes Three-Eye Atlas such a powerful artistic symbol, noted cultural critic Dr. Sophia Chen, is its combination of concrete reality and ultimate mystery. It was indisputably there, yet its true nature remains open to interpretation. That tension between the known and unknown creates a fertile space for artistic exploration. Long after science had moved to newer puzzles, art continued to orbit the mystery. In 2040, the first dedicated interstellar probe, Pathfinder I, launched on a trajectory that would eventually carry it beyond our solar system, following a path similar to that taken by Three-Eye Atlas as it departed. Though the probe would take decades to reach interstellar space and centuries to approach another star system, its launch represented a symbolic response to the visitor's passage, humanity's first intentional emissary to interstellar space. "In a sense, we're returning the visit," remarked Dr. Elena Rodriguez at the launch ceremony. "Just as Three-Eye Atlas passed through our neighborhood and continued its journey, we're now sending our own messenger outward, carrying with it a record of who and what we are." The probe carried scientific instruments, but also cultural artifacts, music, art, literature, and genetic records preserved in radiation-resistant formats designed to last potentially millions of years. Unlike previous space messages, which had been explicitly created for potential extraterrestrial recipients, Pathfinder's cultural payload was designed as much for future human generations as for any non-human intelligence that might encounter it, a time capsule of human civilization at the moment of its first intentional step into interstellar space. Our answer was finally spoken, carried on a vessel bound for stars we would never see. By the mid-21st century, direct memory of the Three-Eye Atlas encounter had begun to fade as the generation that had witnessed it firsthand aged and passed away. The event transitioned from contemporary experience to historical record, preserved in archives, textbooks, and cultural memory. Yet its influence persisted in subtle ways, in research priorities, in philosophical frameworks, in the design of observational technologies, in educational approaches that emphasized cosmic perspective. What's most significant about the Three-Eye Atlas legacy, observed historian Dr. Maya Williams in 2052, is how it fundamentally altered humanity's relationship with interstellar space. Before this encounter, we thought of interstellar space primarily as an empty void separating star systems. After Three-Eye Atlas, we began to understand it as a dynamic environment through which matter, energy, and potentially information constantly flow, a cosmic medium connecting rather than separating worlds. The visitor had shown us that the distances between stars are not empty, but filled with possibility. In 2075, 50 years after Three-Eye Atlas's passage, astronomers at the Lunar Farside Observatory detected unusual radio emissions from the region of HD 162826, the He star system toward which the visitor had adjusted its trajectory during its final observed course correction. The signals were faint and intermittent, just barely distinguishable from background noise, but showed structural similarities to the light patterns previously observed from Three-Eye Atlas. After extensive verification to rule out instrumental artifacts or terrestrial interference, the discovery was cautiously announced to a world that had largely forgotten the original visitor. For a new generation, the mysterious signals sparked fresh wonder and speculation. Had Three-Eye Atlas reached its destination? Was it communicating with something there, or had it delivered some message about Earth to whatever awaited it in that distant star system? The questions echoed those asked decades earlier, but now with the added perspective of an older, perhaps wiser humanity, one that had learned patience from its first encounter with the truly unknown. Across decades and light years, echoes of the first visitor still reached us. Maybe we don't discover the universe. Maybe we simply remember our place within it. In the silence that follows the visitor's departure, we find ourselves changed, not dramatically, not obviously, but in subtle ways that reveal themselves slowly. Like stars appearing one by one as twilight deepens into night, we look at ordinary objects with new awareness of their cosmic origin. The carbon in a pencil forged in stellar furnaces, the hydrogen in water created in the Big Bang itself, the iron in our blood born in supernova explosions. We notice the movement of shadows throughout the day, the patient rotation of our planet beneath the sun. We feel the pull of the moon in tides both oceanic and biological. These things were always true, always present, yet somehow they seem more immediate now, more personally relevant. The boundary between the cosmic and the quotidian has thinned, revealing the extraordinary nature of ordinary existence. Perhaps this is the true gift of Three-Eye Atlas, not answers or technologies or revelations, but a gentle reminder of connection, that we are made of star stuff, as Carl Sagan famously observed, that we exist as conscious nodes in a universe gradually awakening to itself. That separation is illusion. We are the universe experiencing itself from billions of perspectives simultaneously, each consciousness a unique lens through which reality observes its own unfolding. When we look up at the night sky now, something has shifted. The darkness between stars no longer feels empty, but pregnant with possibility, with presences we cannot yet perceive but somehow sense. We understand now that we are never truly alone, not because aliens or gods or spirits watch over us, but because consciousness itself is a universal phenomenon, expressed in countless forms across cosmic distances and timescales. And perhaps in the deep silence of meditation, or the liminal space between waking and dreaming, we might occasionally catch echoes of that greater conversation, whispers from distant awareness, fragments of a dialogue that began long before our species evolved and will continue long after our sun has burned its last hydrogen atom. For now we return to our lives, to our brief moment in the cosmic story. But we carry something with us, a question that has no answer but changes us in the asking. What if everything is listening,